Hello everybody, hopefully you guys had a good weekend. Mrs. Ward was just telling me how amazing you guys' Socratic circle was, so I'm kind of jealous. If we could start with some green check marks and we'll go from there. Just gonna do a quick rundown of Unit 5, kind of what we covered, things like that, and then I'll answer any questions you might have. And that's all I had planned for today. I didn't want to start Unit 6 until tomorrow, so give you guys some time to get through it. A few of you are asking questions about the learning guides and when they're due and things like that. So I'll go through all of that right now. Still a few green checks we're missing. I don't know where you guys are. I have a few. Would love a few more and then we'll get going, just so you aren't missing things. I have a feeling it's just a matter of clicking the button. So, Unit 5 in the course, we've been looking at for a while now. Can we hand in the learning guide today? Yeah, that's completely fine if you want to hand it today. I think one person already handed it in this morning, so that's fine, or maybe the other day. I wasn't at work on Friday. Sick, so I didn't check anything on Friday, but I didn't see a bunch in this morning, so we should be okay. Unit 5 we started with, and we looked at, the first thing was just interpreting information from graphs. Thank you, Taylor. So all the graphs was the first stuff we did. The second thing we did was relations and functions. So the difference between those things, and then domain and range were kind of the trickier sort of concepts there. And then we had the learning guide part 1, which was due. So we kind of broke the learning guide, or I broke the learning guide into 2 parts, kind of break it down. It's not quite as overwhelming when you're looking at, 15 pages of stuff instead of 4 or 5 pages at a time. So submitting the first half of the learning guide here, I think I have about 10 of those out of the 20 of us, so about half of us still need to submit that. And then we continued on in the second half of Unit 5. We did graphs of relations, functions, domain, and range. So talking a little bit about graphing. And then we went on to graphing linear functions, so things that were straight lines, no curves and things like that. And then finally, lesson 5 that we did on Thursday's class was function notation, which was an idea that you've already done. So you've done the math in grade 9 and 10, and it was just kind of a new way to write things. So just using sort of math notation, function notation to kind of write these things again. So hopefully you can wrap your head around that, and that's kind of where we're at. So at the very bottom of the unit here, I have Unit 5 Learning Guide Part 2 is due tomorrow. So it gives you guys today to finish it up, and then we can go from there. And then Unit 5 exam. So I was hoping you guys would write that by Wednesday. So today's Monday. If you don't have any questions next day, you can just write it tomorrow. If you want to come in on Wednesday, we're going to have math support in the afternoon again. You can come in on Wednesday, and then you can write the test after you've gotten any help. So if you would like to do that. So that's where we're at, kind of where we're going. A few people have put in some questions into chat regarding the Unit 5 material. And if you have any additional questions that haven't come up yet and you want to put those in, that'd be great. And I can get to those. So I'm just having a little quick read through the chat here. So domain and range questions, and go over the symbols. Definitely can do that. Unit 6 is ready. I just have to unhide it. I'll do that when I get back to my office after I'm done here. And rate of change, function notation, just for extra practice. Sure. So is that it? Just a few domain and range questions, and then some function notation stuff. And then rate of change, as well. The really great thing about this unit is a lot of the stuff is just kind of looking at graphs and trying to get information from them. So if you can read the labels on the graph, the title, and try to decipher what's going on in the graph, that's part of this unit. So it's a really great way to kind of boost your mark. There's a few kind of hiccups thrown in there, like domain and range stuff can get tricky, and maybe like rate of change, finding the slope of a line, that can get tricky. But other than that, it's hopefully fairly straightforward. I'm going to start with some maybe domain and range stuff, and then we'll go from there. I see a few of you are typing still, so the domain and range in the learning guide wasn't great, but there were some questions here. This is the worksheet that we went through in class. So it had, what did it have? At the top it had a vertical line test to figure out if it's a function or relation. And then we went on to look at some of these other shapes. So these are linear functions, determining the domain and range. And then we looked at some nonlinear functions, determining the domain and range. And then on the very back, the last page, there was choose your own graph and create your own graph on each grid and state the domain and range and whether the graph is a function or not. So maybe I'll just draw a couple lines here and we'll practice our domain and range from there. And then I can go on to some other stuff if you guys have further questions. So I don't know, I'm just gonna randomly, let's maybe start with just a line segment. So let's pick a random point right there. We'll do an open dot there, and we'll do maybe a closed dot right there. And then I'll connect those 2 points with a straight line. There we go. So there's my graph. And then we're going to find the domain and range of that thing. So the idea behind domain and range is the domain is all the x values the graph uses, and the range is all the y values the graph uses. We can just, kind of figure it out. I had a couple different ways to describe it. I talked about like a light bulb on top casting shadows down and up onto the x-axis. If that works for you, then go ahead with that idea. But really the idea is, what x values is the line using? So if I had written these all as ordered pairs, which values would I use? So I would use everything in yellow here. If I wanted to write this as an ordered pair, this point would be -1, 2, 3, 4, 5, 6. So it's -6, and then I've gone down 2. And then if I wanted to write an ordered pair up here for this guy, I've gone over 1, 2, 3, 4, 5, and I've gone up 1, 2, 3, 4. All right, so those are my ordered pairs for those two endpoints. I could pick any point along the line, and I could write an ordered pair for that point. So that would be like -1, +1. So you can see how it's a continuous line, so I'm going to use every x value all the way from this -6 all the way up to this +5. This -1 included in between those two things. So there's a bunch of different ways to write the domain. When we have a continuous line like this, generally we would write it like this. So I'd write my x values are all going to be between, my lowest is -6 and my greatest is 5. Move that over a little bit. Okay, so usually we can kind of get the smallest and largest. Because it's a line, we're using all values between there. So all of my x values are going to be greater than -6, and they're all going to be less than 5. Now, because I have a closed dot down at the bottom, I have the greater than or equal sign here. I have an open dot over here, so it's going to get really close to 5, but it's never actually going to get to 5. So I've left a less than symbol without the equal to below it. So that's one notation. I think they called it interval notation. You can also write it like this. So my smallest x value is -6. My largest was 5. And I have a square bracket means equal to that point, -6 in this case. And then this is not equal to. All right, so that is the notation for our domain, the x values. Remember, domain is x values, and our range is going to be y values. All right, so let's look at our range now. Get rid of my yellow line. The range is all the y values I'm including. So what y values am I including here? Everything from here down to here, and everything in between those. So the largest y value I'm including is going to be 4, and the smallest is 2. So write it like this. That should be -2. Negative sign disappeared. -2 and 4. All of my values are between -2 and 4. Put a y here. They're going to be greater than -2 or equal to, and then they're all going to be less than 4, but not equal to because we have an open dot at the top. And then writing it as we wrote it up above there. So we had -2, comma, and our largest is 4, our round bracket. So this notation only works when you have like a continuous line, the second set. Is that set notation or interval notation? I'm thinking the brackets they're calling interval notation. And then with an infinity sign, do you use a round bracket or a square bracket? It's kind of, you could use either. Generally speaking, with infinity, we're going to use a round one. And the reason we're going to use a round for infinity is because if you use a square, that's implying that it's equal to infinity. But how can you be equal to something that's just infinite? It doesn't really make a lot of sense. So it makes a little bit more sense to use a round one for the anything that's going to infinity. Let's just do one more, and then we'll maybe move on from domain and range. Let's get an infinity one here. I don't know, I'll pick a strange looking thing. I don't like how that little bump in it did the same thing. Oh well, we're going to go with it. So we have this curve, it's this green line, and we want the domain, so the x values that are used. The thing to kind of notice on this line is that this end of my arrow has an arrow, and that means it's going to go on forever, up and up and up and up forever, up in that direction. So this line, because it has an arrow, is going to go up forever and to the left forever. So that's important to note. I have a point at the right side here. So when I'm dealing with x values, I need to figure out what x values I'm using. So this kind of casts a shadow down. You can use all of these x values, and then I'm just going to continue on forever because this arrow is going on forever. So I'm going to use all negative x values. So what is my largest x value I'm using? I guess this point here. What are the coordinates of this point? So my x is 1, 2, 3, 4, 5, and my y is going to be 1, 2, 3, 4. So all of my x values are going to be, is it not 5? Did I miscount? 1, 2, 3, 4, 5. 1, 2, 3, 4. I'm pretty sure I got that. There we go. So we have 5, 4 is our point. So all my x values, I'm not using any x values over here. So I don't want to say I'm using anything greater than 5. So all of my x values are going to be less than 5. So my x values are going to be less than or equal to 5. Or if I want to write it as interval notation or whatever they're calling it, I'm pretty sure it's interval, I'm going to use all negative x values, so I'm going to have negative infinity. And then on this side, I have 5 with a square bracket because I'm including 5 in my interval. So from negative infinity to 5. So that is my domain. My range is going to be my y values. Now this is maybe a little bit trickier, the y values of this graph, because I have this point 5, 4, but that has really nothing to do with my range. So if I'm thinking what y values I'm using, I'm thinking, okay, I need to figure out what's going to happen on my y-axis or my vertical axis. So I'm going to go across. I'm going to use all of these points here. I'm going to use all of these points down here to right here. And then because this arrow is going up forever, I'm going to use all positive y values. So my y values include all of these, and then I'm including nothing lower than the bottom of that little curve. So my smallest y value isn't actually isn't have anything to do with this point up here, that's 5, 4. It only has to do with sort of the lowest, if we can undo that, the lowest value I've used down here at the bottom. So that's 1, 2, 3, 4, 5. We'll pretend it's at negative 6. So my range is going to be y is greater than or equal to negative 6. Everything's going to be greater than negative 6. One question in chat here. If you wanted to, could you put in negative infinity on the other side of x? I'm going to go with no. Up here as the domain. You could, I guess, put negative infinity there and go like that. I guess we don't want to go equal to infinity. Sure. Or you could just say all x values are going to be less than 5. Or you can say it's between negative infinity and 5. That's fine. And then the same goes for the range here. If you wanted to go, I flipped my arrow here, so you could write all my y values are going to be from negative 6 between y and then all the way up to infinity. You do either one of those. Those both make sense. And if we wanted to use our interval notation like we have here, we're going to have negative 6 included all the way to infinity, and then we'll use a round bracket for infinity because we're never sure if we can actually equal infinity because it's just going to go on forever. It's kind of a really weird idea. Does anybody have any further questions for domain and range? You guys put in some stuff about the brackets. We could do maybe one more example with just points, and I could do that, although they're pretty straightforward. If there's anything you're kind of uncertain about with domain and range, I'd be happy to do more. One thing I forgot to do for these questions, because I made them up, but it says, are these functions? And this might be a good little refresher on what a function is. So remember we have for a function the vertical line test. If you can draw a vertical line that hits more than one point, in the first example here I have my blue line. So if I can draw a vertical line that hits that blue line in more than one spot, then it becomes a relation. And same goes here. But in both cases, these are both functions because I can only ever intersect one point on those two lines. If I had something like had a line started here and it wrapped around and went back there. I know there was one kind of like that. I can draw a vertical line and I can intersect 1, 2, 3 points. So that is not a function. No. Because I can intersect it more than one. Alex, are you asking more slightly related to the topic of conversation but slightly off-topic questions? You're going to be that guy in science class that gets me rambling off about something completely unrelated to the course content for just hours, I have a feeling. If it requires infinite energy to go the speed of light, does light have infinite energy? The way that light gets around the whole infinite energy thing is that light has no mass. Photons are massless particles. So it does not have infinite energy. It has a finite amount of energy, but it doesn't have any mass. So that's how it gets around that whole speed of light thing. Pretty tricky, light. Okay, I didn't see anybody put any further questions in regards to domain and range. So if you have something else that kind of comes up later, that's fine. There was some other stuff in chat that we needed to discuss. I'm going to just scroll up here. It's not scrolling. Can we practice determining rate of change in function notation? So yes, we can do both those things. So domain and range, we got that. Haley's right on the Christmas countdown to the hour, which is excellent. Rate of change function notation, and then page 10 of the learning guide. Oh, sorry, number 10, page 7. Well, maybe let's jump to that learning guide, and then I'll go into some stuff on rate of change, perhaps. And where are we at? You guys are talking about the space-time continuum. I like it. I like it a lot. Learning guide part 2, and it was page 7, number 10. Got my page all wonky here. Page 6, page 7, number 10. Okay, I like this question. This is a good one. And then we'll get on to, and also C for number 12 on page 9. Page 8, 9, number 12, C, determine the rate of change, describe what it represents. Perfect. So I think that will do nicely for that stuff. Okay, so the question here, it doesn't really tell us a lot about this graph. It asks, what is the cost of hiring a carpenter for 8 hours? And you're probably thinking, oh, awesome. I can just kind of go to my graph and look up 8 hours, and then I can figure out how much it costs. But you can see the graph here, my pen's wonky. The graph only ends at 5 hours here. So 6, 7, 8 is going to be way over here, and then I don't have any data up here. So this is kind of a bit of a tricky question. So what I can do is kind of see if I can get some information from my graph. So the first thing I notice is my graph doesn't go through the origin or my 0, 0 point here. And then we're at this point here to start. So this is between 40 and 80, so this is 60. And what do we think that $60 represents? What do we think that is? Any ideas? So that's speaking about the cost of hiring a carpenter to begin with. So that's what Ava has here in chat. So before we've even, this person's even looked at our building project, they're going to just charge us that $60. So that's the cost before any work has been done, I guess. So we're hiring a carpenter. All right, so that's kind of the first thing. It's the amount of money to hire the carpenter before anything's done. Perfect. So let's look at this. After 1 hour, where are we? We're up here at That's halfway between 80 and 120, so that's 100. And then at 2 hours, we're at 140. So if you think about it like this, after 1 hour, I've been charged my $60 initial fee plus an additional $40. Does that $40 per hour hold up if we go to 2 hours? So let's look at 2 hours. I can see at 2 hours, I'm getting charged $140. So if I subtracted that 60, I'm left with $80. And is that 40 times 2? Yeah, that looks like 40 times 2. So here, this is $40 per hour times 2 hours. So it looks like every hour the person works, they earn $40. And then we have that initial $60 to consider. So a couple ways you can think about it. If you want to just, say, okay, 8 times 40 is 320 plus your initial 60, you could just add that on and you get 380 and then away you go. Or if you're kind of thinking in terms of like, if there's many questions regarding this one question, you could write some sort of equation. You could say the cost is equal to the initial $60 plus $40 times every hour worked. So if I work 0 hours, it's 40 times 0. If I work 1 hour, it's 40 times 1. I could put 2 in there or 3. But the question specifically is asking for 8. So what I'm going to do is I'm going to take the $60 and then I'm going to go 40 times 8. 4 times 8 is 32. So I'm going to get 60 plus 320 is 380. So the cost of 8 hours is $380. So you can think of it that way, or you can just kind of work it out in your head, or what I've seen students do on graphs before, which I don't love it, but they've done it. They'll actually continue the graph over, and then they'll put in 6, and then 7, and then 8, and they'll continue these points up, and then all of a sudden they've got this huge graph, and they've drawn all these grid lines. And really, I'm not here to say which way you need to do the question. If that's the way that makes the most sense, trying to continue that graph on to make it bigger, to expand it, and gets you to the right place, then why not? There's probably maybe simpler ways to do it, but if you get on a test and you're like, oh, I don't know how to figure that out, and you just kind of freeze and you think, oh, I could just make the graph bigger, then you know that's a valid way to answer a question. So there you go. So it looks like you kind of sorted it out. Oh, I know what I did wrong. I used the rate of change, but forgot the initial rate. So the rate of change in this case is 40. The slope of the line is 40. So $40 every hour. And then you forgot that initial 60. So that's kind of the, that works. And then Talia went 190 times 2 because 4 hours plus 4 hours is 8. I think you might run into a problem with that method, Talia. You're going to use the initial $60 cost twice. So that's going to be a bit of a problem with doing it that way. So just something to consider there. Alex, you're still on the light. I love that you love science so much, yet every time we talk about science, you try to convince me that you hate science. But yes, you can see if you have a fast enough camera, light travels different speeds in different things. So light travels slow in water, and you could watch it moving through water, I guess. Very interesting stuff. I think there was one other question off the learning guide here, 12C. Aaliyah was asked by a friend to take over delivering catalogs for 1 day below is a graph that represents the income earned for 1 day's work. So I guess it depends on how many catalogs, and you can see that there's an arrow on the end here, so it's going to just continue on forever, depending on how many catalogs you deliver. So I guess there's lots of jobs that kind of exist like this. Some people go tree planting in the summer and you get paid per tree. Or you can pick apples, especially in the Okanagan, because we have so much fruit here. You can pick fruit and you get paid, per pound of fruit you pick. So the harder you work, the more money you can make. And these are kind of interesting jobs. You don't get paid per hour like other jobs. So the y-intercept, I'm just going to maybe go through these. The y-intercept is 30. And I guess you just get paid $30 a day. Not 30. What am I talking about? 10. So this is 15, 20, 25. So 15, sorry. $15. That's kind of just how much you get paid per day. A real tough time writing today. How much you get paid per day. You don't have to deliver a single catalog. Just for taking this job, you get paid $15 every day. You deliver some catalogs. The rate of change is going to be a fancy way of saying slope. So what is the slope? Okay, let's pick some points. Now I'm going to try to pick points that go through perfect grid points. So that's an easy one to deal with there. And then, I don't know, I see one kind of going through here. I could use one here, or I could use one here. Doesn't really matter where you pick. Let's go with maybe 30 and 30. That's going to make the math perhaps a little bit straightforward. So I've got these two red circles, and I'm trying to figure out my slope or my rate of change. I'm going to just do the calculations over here. So rate of change, another way of saying slope, or we could say rise over run. So those are all the same thing. All right. Remember, the rate of change is asking how much, like the previous example, the cost per hour, how much they charge per hour. Or in this case, we have income divided by number of catalogs. So it's going to be the how much we get paid per one catalog or per catalog. So the rise, I'm going to figure out how high I need to go if I start at this first circle to get up to the second circle. So what is my rise? I've gone from 15 and I've gone up to 30. So how many did I go up? Well, I started at 15 and then I went up to 30. So I've risen either, if you think about it this way, 30 minus 15, which is just the same thing as 15. So I've gone up 15. And then my run. How far do I go over to get from here to here? Well, I started at 0 and I went all the way to 30. So my run is 30 minus 0, or just 30. I guess I could write it over here. 30 minus 0, which is just the same as 30. So this is my dollars on top, and then I have the number of catalogs on the bottom. So what does this mean? Taylor's already got the answer in chat. 15 divided by 30 is $0.5 per catalog. Abby's saying I did $1 per 2 catalogs. That is right, Abby, but this is the kind of tricky thing about rate of change. The rate of change is always written per 1. So although it makes more sense to say you get $1 every 2 catalogs, if you're just talking to somebody in conversation, the rate of change is concerned with the cost per catalog. So how much it costs per catalog. Or in the previous example we looked at, it was the cost of the carpenter per hour. So the idea here is we need to forget about the initial $15 a day. It has nothing to do with how much we get paid per catalog. So the rate of change is just going to be the cost per one catalog. So we get paid 50 cents per catalog. I think that was the question. Determine the rate of change or the slope. Yes, $0.50 per catalog. which is the rate of change, and the description, this is the amount of money for delivering one catalog. I think that was it for that question. Yes. All right. So that kind of covers rate of change. And as I said, I told you a little story about my physics teacher who just said, if you don't know what to do on a graph, just find the slope of the line. Rise over run, rate of change, the cost per catalog, whatever way you want to think of it. There's lots of different words to describe what the slope is, but there's very few graphing questions that will not require you to find the slope. All right, so is there anything that I didn't cover? Amount of money in hire carpenter, I got all that stuff. I think there was something that I didn't cover. Number 10, I did those. Interval notation, domain and range, we got those out of the way. The brackets, there was some function notation stuff. I haven't covered any function notation questions yet. And yeah, just reading through chat, I think we're good. Is there anything other than function notation you guys would like to perhaps cover? I'm gonna go back to the course maybe, and I'll find some function notation questions. I'm gonna go into the extra practice on this. Let's junk out of the way. Practice assignment for function notation. I can't write on this because it's not loaded into my notepad, but maybe I can bring a few questions over and we can go through a few of them. Perfect, Alex. I see your question there in chat, so I will definitely go page 7, question 8. You're going to look at a little bit of function notation stuff first, and then I'll get that. And Abby, I think that's super true about function notation. It's one of these things where it's just kind of replacing letters that you're normally used to seeing with just a new way of writing things. So there's really no reason for it to be kind of overwhelming or just kind of, I know students kind of get lost in it sometimes because it's new, it's different, but it doesn't need to be that way. You could just change all of these function notation questions and something you're familiar with, answer them, and then just kind of go back into the notation it started with. So that's maybe a good way to deal with these types of things. So this example here, 2x minus 7. So f of x is 2x minus 7. Let's maybe look at a few questions like that. So this is function notation. F of x is 2x minus 7. Now I don't remember what the questions look like on that page, but I have a feeling there's something like find f of 3. Maybe we can start with that. So this is function notation. Remember we say this f of x. Now, if we're looking at it, we can see that this x here is now been replaced with a 3. So what I'm going to do with my equation is I'm going to replace my x with a 3. Because this is saying everywhere there's an x, I want you to put in a 3. If you don't need to write this down, you can think of it this way. Y is equal to 2x minus 7. You've done questions like this before, and someone says, solve when x is equal to 3. And you say, okay, y is 2 times 3 minus 7. It's the same question you guys have done before, except we're just changing what it looks like. So let's find f of 3. We'll just continue on. 2 times 3 is 6 minus 7. F of 3 is negative 1. If I'm looking at this, I get y is 2 times 3 is 6 minus 7. y is equal to negative 1. So these are the same things. I could say, okay, f of 3 is equal to negative 1, or I could just say when x is 3, y equals negative 1. They're identical mathematically, but the only difference is this is just the kind of notation you're going to see moving forward in math. So that's maybe a pretty basic function notation type question. You could put any value in you want for x, anything. Negative 1, 72, 3 million, you just solve it like you normally would. Follow your BEDMAS order of operations, see what the answer equals. So that's kind of the first sort of stuff in function notation. There's some other questions. I mean, looking at number 3 here, they've given you an x squared. So when you're doing your BEDMAS, you just have that exponent to deal with in the correct order. So that's something you've seen before. F of x equals negative 2x plus 3 for what values of x give each of the following values for f of x. Okay, so maybe let's do one question from number 4 here, because this is kind of the backwards sort of way. So f of x equals negative 2x plus 3. Let's start with that. So this is number 4. F of x, I'm going to write down the same thing I just wrote. Make sure I get it right. Negative 2x plus 3. All right, so what these types of questions are saying is, okay, f of x is kind of like y, same thing. So let's let y equal, try to pick something that's going to work out nicely. 8, 9, 10, 12. Let's go with 12. They're saying f of x is equal to 12. So the function is equal to 12. What does x equal? So what you're going to do is you're going to go 12 is equal to negative 2x plus 3. And then you're going to solve for x. So we're going to subtract 3 from both sides. Still didn't work out like I was hoping. Oh well. 12 minus 3 is going to give me 9. Is negative 2x. And then I'm going to divide by negative 2 on both sides. And I'm going to end up with negative 4.5 is equal to x. Now that is function notation. This is kind of the alternative, the or. If I said y is equal to negative 2x plus 3, you've seen that before. And I say let y equal 12, solve for x. You'd say, okay, 12 is equal to negative 2x plus 3. You'd move the 3 over and you get 9. And then you divide both sides by negative 2 and you get negative 4.5 is equal to x. It's the exact same thing. You end up with x is equal to negative 4.5. So, I know, Taylor, the first few times I got into chat, and I always write students messages, and sometimes I put things in brackets, and every once in a while it turns it into one of these little emoticons, and everything just looks a little bit bizarre. So, not your fault, Taylor. I don't get f of x equal to y, or why is there a person? Yeah. It's just a different notation for moving forward in mathematics. It is easier to deal with when you get into the types of questions you're going to see grade 11 and 12 and then calculus. It's trying to prepare you for calculus. This is one of these things where we're teaching you stuff now that's kind of the foundation or building blocks for calculus, even though many of you will never take a calculus course in your life. But we're trying to prepare you for calculus, but you don't know what calculus looks like because you've never seen it before. And you can't see kind of the end goal, but you're just kind of caught in the forest right now. So right now we're walking through the forest. All you can see is trees. But on the other side of the forest, there's this beautiful field called calculus. You're going to get out, you're going to look at it. There's going to be deer prancing through the field, and it's just amazing. You can't see any of that yet. There's just trees in your way now. So eventually you'll, get to the other side of the math and you'll see the beautiful deer dancing in the field. If that makes any sense. Probably not. So these are all the same sorts of questions with just different functions. So that's kind of function notation in a nutshell. They can ask you questions on a graph, and there's sort of the same idea. If you want to go f of x is y, and then everything on your vertical axis is your y's or your f of x's, you can. That's just kind of the way it works. Alex, you had one question from the learning guide, and I think if any takeaway from today's lesson is calculus is equal to deers prancing through a field, then I guess that's what you got out of it. I can't argue with that. You were paying attention enough to get that. If you don't take calculus, but if you continue with math, you'll go to Math 12 and you'll get through the forest, and calculus will be there waiting for you. You just might not choose to continue to walk and prance through the field. You might just decide to stop. Say, that's enough. I've seen the field. I don't want to see any more of it. What was your question, Alex? I'm going to scroll up here. It's a little faster. Page 7, number 8 from the learning guide. Page 7, number 8. Why are some points joined together on a graph and other times are not joined? All right. This is a really good question, and even looking at some of the stuff we've done in the learning guide, cost of hiring a carpenter per hour, not connected. Volume of water in a tank is a straight line. All the points are connected. Something like this. Friend to deliver catalogs. Why is that connected? This one didn't really have anything other than just an f of x. So why do we connect points? Let's maybe think of something in terms of like donuts. You go to Tim Hortons and you buy 10 Timbits. I like Timbits because they kind of look like dots on a graph, and I like Timbits just in general. So if I said, okay, plot a graph of the cost per Timbit, and you have cost here, and you have number of Timbits here, and then I have some points. If I have 0 Timbits, it's $0. So I'm gonna slide out of the way. If I have 1 Timbit, I have $1. If I have 2 Timbits, I have $2. 3 Timbits, $3. Would it make sense to connect those Timbit points, those red Timbits? Can you go to the Timbit store, Tim Hortons, and say, I'd like 1 7/8 Timbits or 1.5 Timbits, please? No, you can't. You can only buy whole Timbits. So in something like this, where I have dollars per Timbit, I wouldn't connect my line because that would imply that I can have every sort of thing in between. So this is 1, this is 2, this is 3. I don't have anything between 2 and 3. So we can't have 2.5 Timbits. It wouldn't make sense. Yeah, 82.217. They'd give you the 82 and get very confused by the 0.217 of a Timbit. You can just imagine some poor Tim Hortons employee gets out a cutting board and a knife and tries to cut you 0.217 of a Timbit, and you say, I'm sorry, that's clearly 0.23 of a Timbit. I asked for 0.217. So in a situation like that, it's not going to work. The other example we looked at was a cost of hiring a carpenter per hour, wherever that one went, right here. So this carpenter charges per hour. If he works, 1 hour and 2 minutes, you're into the second hour. He's charged you for the second hour. And people work like that. It's kind of like phones. If you have a cell phone, you get charged per minute. So if I'm talking to you on my phone, and I'm talking, and then it's like 1 minute and 1 second. As soon as I get to that 1 minute and 1 second, it rounds it up to 2 minutes. And then I get charged for the 2 minutes. So I can never get charged on my cell phone bill for 2.5 minutes or 2.2 minutes. It's always going to go to, okay, you've passed 2 minutes, boom, 3 minutes. You get billing by the minute instead of billing by the second. Whereas a question like this one here, wherever my water one went, a water tank holds 12,000 liters, and then this is how much water is in the tank per liter or per time. So the water is emptying out of the tank. Could you have, like 60.2174 liters? Sure, you could. I doubt you'd have anything that would, accurately measure that, but you could conceivably have that. Or you could have, like 63.724179 liters. So it's a continuous line because you can have values between, 60 is down here, you got 64 up here. You have everything in between those whole numbers. So we're going to have a continuous line there. So there you go. Hopefully that answers the question in kind of a roundabout way. Sometimes we have a line that's connected and sometimes we don't. It just depends on the question. Depends on what you're talking about and sort of what context you're talking about it. So Abby's now concerned about cell phone bills. $1 per second on my phone bill. Yeah, some bills are per second. It just depends on your bill. I usually pay per minute billing or per second billing. So the difference between the two can be substantial over the course of a month. So there you go. I'm going to leave it at that for today. I don't see a ton of questions coming in regarding the material. So we spent an hour kind of looking at most of this stuff, a little bit of a review. $1 per second would be a little bit much, but I think I got the idea of what you're saying. So Unit 5 review, a learning guide, I should say, should be in now. Both part 1 and part 2 should be done. You get the part 2 in and you've got part 1 in. I'll send you guys the password for the next test, the chapter 5 one. I was hoping you get the learning guide in today or tomorrow and then have the test written by Wednesday. If you want to come in for help on this stuff on Wednesday, we'll be here 1 to 3 o'clock Wednesday afternoon. I'm going to start Unit 6 tomorrow. I'll open up the worksheets and the learning guide for Unit 6 right now. And that's it. So have a great afternoon, guys, and we'll see you tomorrow.